Thanks to films like Jurassic Park and games such as Jurassic World Evolution, we now have a vivid image of the greatest dangers that ever walked the Earth. We believe we know what dinosaurs looked like millions of years ago, how they moved, and what bone-chilling sounds they might have produced. But how much of this is actually supported by science? Do paleontological findings match the portrayals in pop culture, or is reality being bent for the sake of entertainment? Today, we'll look at several examples from the Jurassic Park franchise and examine how realistic these depictions actually are. Determining this, however, is far from straightforward. Fossils have fascinated humans since ancient times, including in ancient China. Later, scholars such as Eratosthenes and Leonardo da Vinci interpreted them as the remains of long-extinct organisms. It was not until the late 18th century that modern paleontology began to take shape. The French naturalist Georges Cuvier eventually came to the realization that the complete extinction of species is a real phenomenon that has occurred repeatedly. Darwin's theory of evolution offers a complementary concept, showing that life continues to change even after extinctions. Since then, research on dinosaurs has continued to evolve steadily. Unlike fossilized remains themselves, our scientific understanding of prehistoric species is constantly changing. Each decade brings new discoveries, continually reshaping the picture we have of animals like Velociraptor and Allosaurus. It is therefore hardly surprising that pop culture portrayals of these giants become outdated and often appear inaccurate from today's perspective. At this point, it's worth noting, we are not looking to criticize the films, but rather to highlight the fascinating evolution of scientific understanding and to show how pop culture has interpreted it. One of the most well-known and beloved species from Jurassic Park is the Velociraptor. It is one of the franchise's most iconic creatures and has strongly shaped the public perception of small theropods. So it's hardly surprising that it appears in several films, including the original Jurassic Park from 1993 and the newer Jurassic World movies. However, by today's scientific standards, it quickly becomes clear that the Velociraptor in Jurassic Park differs significantly from its real-life counterpart. In the films, it is roughly as tall as a human and reaches a length of 3 to 3.5 meters. Its skin is covered with scales and completely lacks feathers. It is portrayed as an aggressive yet highly intelligent predator, capable of complex pack tactics and even opening doors. With its 15-centimeter long sickle claw, it slashes its prey instead of biting. In reality, the Velociraptor of the late Cretaceous period was significantly smaller. It reached a maximum length of around 2 meters, barely coming up to a human's hip. Its lightweight body made it appear far less massive than it does in the films. Furthermore, it is now certain that Velociraptors were feathered. In 2007, researchers discovered clear attachment points for feather quills on an exceptionally well-preserved forearm bone. Its sickle claw likely functioned differently than depicted in Jurassic Park. Instead of 15 centimeters, it measured only about 6.5 centimeters. While the Velociraptor did use it in combat, it did not rely on it exclusively. The claw was also adapted for climbing, meaning it was not solely a deadly weapon. There are also behavioral differences between the Velociraptor in Jurassic Park and what paleontology suggests. The Velociraptor is thought to have been fairly intelligent, likely above typical reptile levels and comparable to modern birds and crocodiles, but there is no evidence for complex pack hunting. It is much more likely that Velociraptors were opportunistic predators, hunting primarily alone or in loose groups. They were clever, yes, but not strategic geniuses. The portrayal of Velociraptors in Jurassic Park is among the most inaccurate in the entire franchise. But why is that? The key here is the Deinonychus. When the first film was conceived and filmed, it was still unclear whether Deinonychus was a subspecies of Velociraptor. Since this theropod appeared significantly more fearsome, it was used as the model for the depiction of Velociraptor. Anatomically, Deinonychus corresponds much more closely to the Velociraptor shown in the film than the real Velociraptor does. It could reach lengths of over 3 meters and had a robust build, yet it most likely had at least feathered forearms, which were omitted in the film. Its sickle claw could grow up to 12 centimeters, allowing it to be used far more aggressively than the Velociraptor's claw. Whether Deinonychus hunted in groups is still debated today. Many researchers consider it possible that several individuals teamed up to hunt larger prey and may have lived in groups for extended periods. However, the exact strength of their social bonds remains a matter of speculation. So Jurassic Park doesn't show a real Velociraptor, but it also doesn't depict a completely fictional one. Its design was based on fossil evidence that was not yet fully understood, and features like feathers had not been confirmed at the time. Moreover, the emphasis was clearly on impact. These dinosaurs were meant to be seen not as cute prehistoric creatures, but as terrifying predators. Yet the Velociraptor is not the only dinosaur to appear significantly altered in the franchise. The Dilophosaurus makes its most famous appearance in the original Jurassic Park film from 1993, though it also appears in the later Jurassic World movies. Although it only had a brief scene in the original, it has since become one of the most iconic misrepresentations in the entire series. In the films, it appears fairly small. It reaches roughly the height of a human's hip and is notable for its expandable frill. On top of that, it has a vicious spitting attack, shooting a poisonous substance at its enemies. As a result, Dilophosaurus comes across like a mix between a Komodo dragon and a frilled lizard, a true science fiction monster. The real Dilophosaurus from the early Jurassic looked completely different. At up to 6 meters in length, it was roughly twice as large as its film depiction and counts among the largest known theropods of its time. The colorful frill from Jurassic Park is pure fiction and was entirely invented for the film. The 2 prominent crests on its head, however, do correspond to the scientific understanding of Dilophosaurus. These crests were, however, nearly useless as weapons, being relatively thin and delicate. It is far more likely that they served a social function, for example in courtship displays or as a means of intimidation. Unsurprisingly, there is also no scientific evidence for spitting venom. Dilophosaurus had neither venomous teeth nor venom glands, and fossils show no indication of any kind of spitting mechanism. In fact, there is no known dinosaur that produced toxic secretions. The film's depiction of the Dilophosaurus spitting venom was instead inspired by spitting cobras, which today can be found in places like Africa. These snakes are capable of projecting their venom up to 3 meters when threatened. In doing so, they lift their heads off the ground and flare their necks, almost like the Dilophosaurus in Jurassic Park. The cobra's venom is expelled through its fangs and has no effect on the skin. However, if it gets into the eyes, it causes a burning sensation and can even lead to permanent blindness. The neck frill of the Jurassic Park Dilophosaurus is inspired by modern frilled lizards native to Australia and New Guinea. When threatened, these lizards extend a large, collar-like flap of skin around their necks. This startles potential predators and gives them enough time to flee on 2 legs. Even here, the filmmakers can't be blamed too harshly. When Dilophosaurus became famous through Jurassic Park in the 1990s, there was still little solid information about the theropod's actual appearance and hunting behavior. This gave the creative team behind the films more freedom. To avoid confusion with the bloodthirsty Velociraptor, they needed unique features for Dilophosaurus, hence the creation of the crest and the venom-spitting attack. The Gallimimus has its most notable appearance in the original Jurassic Park, although it recurs in later films as well. In the original, the slender theropod is shown as a herd animal. The large group moves like a flock of birds, reaching impressively high running speeds. The body of Gallimimus is built much like that of an ostrich, with very long legs and a small beaked head perched atop its long neck. In Jurassic Park, however, no feathers are visible. Instead, its body is covered with a scaly, leathery skin. The franchise gets the general body structure of Gallimimus quite right. Its horizontal posture extended over a length of nearly 6 meters, with the long, stiff tail serving as a necessary counterbalance. It was a fast runner that lived in herds, as confirmed by fossilized group finds. However, it most likely also had a coat of feathers, which the films omitted. In the Jurassic World trilogy, Gallimimus is even shown with teeth, something the real animal no longer had. Nevertheless, Gallimimus remains one of the more accurate dinosaur examples in the franchise. The series is at its most convincing when prehistoric reptiles are portrayed not as monsters, but as real animals, a point underscored by the next candidate. While the portrayals of Velociraptor and Dilophosaurus in Jurassic Park are highly inaccurate, the Parasaurolophus fares much better. In the first film, it only makes a brief appearance in the background, but in The Lost World, Jurassic Park, it gets more time in the spotlight. It also appears occasionally in the modern installments. The Parasaurolophus is a herbivorous herd animal, often seen grazing peacefully in the background. When it takes center stage, it is usually as prey. In the film, Parasaurolophus reaches a length of nearly 10 meters and generally moves on 2 legs, with its long tail balancing its massive body. On its head sits a long, backward-curving cranial crest, which is already well developed in juveniles. By and large, the filmmakers here adhered to scientific knowledge, even though Parasaurolophus in the late Cretaceous was somewhat larger and more robust. It was one of the largest duck-billed dinosaurs, so-called hadrosaurs, in Earth's history. The prominent bony crest on its head is depicted fairly accurately. It was a long, hollow tube extending backward over the head. Researchers have long debated its function. Until the 1960s, some believed that Parasaurolophus was amphibious and could breathe through the hollow crest, but this has been thoroughly disproven. There simply is no opening that would allow this. Today, it is thought that the impressive structure primarily served a visual function for species and sex recognition, and possibly acted as a resonating chamber for calls. However, the crest in juveniles was not as pronounced as shown in the films. As Jurassic Park correctly shows, Parasaurolophus was capable of running on 2 legs, especially in dangerous situations. When it felt safe, it would support itself on its forelimbs and move more slowly on all 4s, for example, while grazing or drinking. Since we mostly see Parasaurolophus fleeing in the films, its quadrupedal gait is somewhat underemphasized, though it is occasionally depicted correctly in the background. Herd behavior is also supported by fossil evidence, including mass death sites and nests. As for its coloration, there is virtually no scientific evidence, so Jurassic Park treats this purely speculatively. We can assume that as a hadrosaur, Parasaurolophus was not feathered. Parasaurolophus is one of the most realistically depicted dinosaurs in Jurassic Park, even if it is probably not the biggest star of the franchise. The next example, however, tells a very different story. The Tyrannosaurus Rex is the symbolic flagship of the film series and appears accordingly often, and when it does appear, it is usually the center of attention. It is massively built, measuring about 13 meters from head to tail, and moves dominantly on 2 legs. Its loud roar and heavy footsteps make the environment tremble, while its gigantic, sharp teeth flash menacingly in the dark, even when its mouth is closed. The most famous survival rule when encountering a T-Rex in Jurassic Park is based on the idea that its vision is movement-based.
Its vision is based on movement.
According to this idea, it would overlook prey that remains perfectly still, often leaving the heroes in the films with no other option to outsmart this unstoppable natural predator. Regarding the size and build of Tyrannosaurus rex, the depictions in Jurassic Park align with scientific understanding. During its life in the late Cretaceous, it could reach up to 13 meters in length and weigh around 9 tons. This made it the largest known tyrannosaurid and one of the largest land-dwelling predators to ever walk the earth. Yet despite its imposing presence, it was still capable of subtle maneuvers. T-Rex had padded feet, which helped it move stealthily during hunting without shaking the ground. In general, it was a more dynamic runner than the films suggest. While not extraordinarily fast, it was significantly more agile. Its roar likely sounded very different from what we hear in Jurassic Park. While the cloned T-Rex emits a thunderous, elephant-like bellow that can be heard for kilometers, the real Tyrannosaurus probably only produced deep rumbles. These rumbles were no less intimidating, reaching frequencies that could be felt through the bones. The T-Rex's long banana-shaped teeth were only visible when it opened its mouth. Unlike in the films, they were likely covered by lips when closed, probably a design choice to make it appear even more menacing on screen. The filmmakers also took creative liberties with its vision for dramatic effect. In reality, Tyrannosaurus rex had highly developed binocular vision. Its eyes were positioned more forward than in most other theropods, giving it exceptionally precise depth perception. In the film, this discrepancy is explained by the fact that the DNA used for cloning was mixed with frog DNA. Frogs, like most amphibians, are particularly sensitive to movement. Static objects, such as plants, tend to fade into the background for them, while jumping insects like grasshoppers and flies are detected with remarkable precision. The Tyrannosaurus rex in Jurassic Park is less a fantasy creature and more an exaggerated version of an already extreme animal, making it one of the more realistic depictions in the franchise. The Spinosaurus appears in far fewer films, yet it was originally intended to surpass the T-Rex. It appears primarily in Jurassic Park 3 and Jurassic World Rebirth. In the former, it serves as the main antagonist and is deliberately portrayed as a new, larger rival for Tyrannosaurus rex, a massive apex predator designed solely for hunting on land. It moves on its long hind legs and is notable for its tall sail, while its tail tapers to a point. This portrayal changes in Jurassic World Rebirth, where it propels itself through water using its paddle-like tail and moves on all fours on land. In both cases, the Spinosaurus is portrayed as extremely aggressive. It is shown taking down an airplane from the air and killing a T-Rex almost casually. The more recent depiction in the latest film, Jurassic World Rebirth, comes significantly closer to the scientific understanding of Spinosaurus than the version in Jurassic Park 3. The theropod that lived during the Cretaceous was likely far less aggressive. While it was indeed larger than Tyrannosaurus rex, it was less robustly built. For a theropod, Spinosaurus had unusually short hind legs and a forward-shifted center of mass, making it much more likely that it moved at least partly on all fours. As a semi-aquatic fish-eater, it spent a large portion of its time in water. Its long, flat body and paddle-like tail allowed it to glide through the waves. Spinosaurus was a wading generalist with a crest on its head and a prominent dorsal sail. The function of these features is still debated, with hypotheses including thermoregulation, display behavior, or stabilization while diving. Spinosaurus is an excellent example of how scientific understanding has evolved over the lifespan of the franchise. It was not until 2010 that a study suggested a semi-aquatic lifestyle for the theropod, and in 2020, a robotic tail modeled after Spinosaurus demonstrated that it could generate propulsion while swimming. At the time, Jurassic Park 3 was made in 2001. These insights were still far in the future. This also shows that the discrepancies between Jurassic Park and modern science are less a result of artistic license, and more often a reflection of the limits of knowledge at the time. In a way, the films preserve the state of paleontology as it existed when they were made. The real insight, then, is not which dinosaurs were portrayed incorrectly, but how dynamic and ever-evolving science itself is. Dinosaurs no longer change, but our understanding of them certainly does.